How's it going? Keith Townsend from the CTOadvisor.com, www.thectoadvisor.com. Check it out. We refreshed the web page a little bit to adjust to the new role as the CTO advisor full time. Today's day number one. So, great feedback on Twitter and LinkedIn on topics for the CTO Daily Dose. Today, we're going to talk about applications that don't necessarily work well in the cloud. We have this mantra that the cloud is just someone else's computer. That's true. Yes, it is someone else's computer, but there are some caveats. It's just not as simple as saying that I'm going to take QuickBooks and install it in the cloud and everything works fine. We're going to go over some applications or some application designs that don't necessarily work well in the cloud. We're going to follow up the conversation with some great input from Mark May. Today's the CTO Advisor Daily Dose topic comes from Udine Porter de Leon. Tomorrow we're going to talk about licensing in the cloud and how you need to consider licensing. So let's talk about first why the cloud is more than just someone else's computer and why we need to actually consider the impacts of moving applications, specifically older applications or older application architectures to the cloud. So this is generically can be applied across the three major cloud providers: Google Cloud Compute, Microsoft Azure, and AWS, Amazon's AWS and EC2. One of the things that we really need to conceptualize is that networking, believe it or not, is one of the largest concerns when it comes to applications. Networking is not the same in the cloud as it is on premises. What does that mean practically? Well, most of the networks in the cloud, from the three major providers, are all TCP/IP based. And you might say, you know what? TCP/IP is the standard and that's good. What's the problem, Keith? Well, some applications, especially clustered apps that rely on technologies such as multicast for discovery. So a common way to form a cluster is for let's say this is your primary machine and your controller, and these are all slave nodes that add to the cluster. What would happen is the primary machine would send out a broadcast or multicast onto the network and say, hey, who else runs this application and wants to join the cluster? As these machines answer, the cluster is formed, and now you have a clustered application with several machines participating in the cluster. This technology is based off a lower protocol than IP, TCP/IP, IP addressing. So where we normally have an IP address of like 192.168.1.1, let's say that's this master machine. And he sends a IP packet to 1.2 and 1.3 and 1.4 to join the cluster. That's not what's happening in these legacy applications. They actually use more of a, if you know anything about networking, a MAC address type of broadcast to say, you know what, I don't know what your IP address is. I'm just going to send out a blanket set of blank package that says, hey, I'm this application, respond to me at this IP address if you're running this application. That just simply doesn't work in the cloud. The cloud doesn't allow for that low level addressing. So clustered applications that are designed to use multicast or broadcast to form a cluster will break. This is not just clustered applications. Some HA applications. So let's say that you have a primary passive, active passive node, and that communication back between the two nodes to understand who's up and who's down. A lot of times that protocol is a multicast or broadcast protocol. So that design won't work in the cloud. This application's clustering mechanism has to be rewritten to account for this change in networking. That's a big surprise to a lot of folks. So the second application that I wanted to take a look at is analytics. So this is fairly true when it comes to virtualization as well as cloud. Analytics applications or high performance compute are applications that people usually frown upon when it comes to putting in the cloud. Simply put, you need more CPUs and more virtual CPUs to get a similar performance as you would in your data center. So in your data center, and you guys have seen this before, the great thing about virtualization is that you can take a physical machine, carve it up, and just as long as you add as much memory as you can afford, you can run a whole lot of applications on one physical platform. We just did a podcast with Intel talking about their Optane technology and how adding the Optane drive resulted in 2.5 times performance increase because of the increased I/O that the Optane drive provides. That's capable because most of us run our CPUs underutilized. You might take a look at your VMware or Hyper-V cluster and say that, you know what, I'm only using 20% of my CPU and I've run out of memory. Analytics applications are the complete inverse, or they're the argument against that. Analytics applications was use as much CPU as you can possibly use. So instead of carving up a single PC and being able to run that application across a single PC, you get into that clustering situation where you can consume in your data center as many physical nodes as possible because CPU becomes the bottleneck. So any CPU intensive application that you put into the cloud is going to have problems because the cloud is based on virtualization technology. Oracle is trying to solve that problem by giving you options for bare metal cloud. So instead of provisioning a VM, you might provision a full machine, and now you can run those analytic type tough applications. So I'd be interested to see how something like an in-memory database, SAP HANA, runs in the cloud. Obviously, HANA is very CPU to memory intensive. That relationship is very intense. SAP puts tight controls on that. In our data center, we can mitigate that by loading VMware vSphere onto a physical host and giving SAP HANA workload the full host. There's argument on whether or not that virtualization tax is worthwhile, but in the cloud, you don't have that option. You don't have those. CTO Advisor, CTO Daily Dose, and we'll talk more about these interesting topics. Talk to you guys later. You can reach me on the web at CTO Advisor, on Twitter. TheCTOadvisor.com is the website. Thanks.